Welcome to Mickey Study Circle channel. In this video, we shall see how to do the manual drafting of the orthographic projection of solids. So here we'll consider a problem based on a cube, which is also a hexahedron. So the problem statement goes like this. A cube of 40 mm side rests on HP on an edge which is inclined to VP at 30 degrees. Draw the projections when the lateral surface containing the edge on which it rests makes an angle of 50 degrees to the HP. Also, after the drafting, we need to find the apparent length of the axis of the cube in its final position. So before we start with the problem, let us make a few key notes from the problem statement. The first thing is the solid type. So we know that the solid type is a cube, which is also a hexahedron, and it is measuring 40 mm with its base length, and this is also the measurement of the axis. So both the base and the axis shall measure 40 mm. The next key point here is the resting condition. It is resting on the edge. So the resting condition is the edge on which it is resting is also inclined to VP. So now we'll take the condition of the inclinations. So with respect to the VP, it is the edge on which it is resting is inclined to VP at 30 degrees. So the angle is phi. And with respect to the horizontal plane HP, it is the lateral square face containing the edge on which it makes an angle of 50 degrees. So this is the value of theta. So this is the lateral square face. Lateral square face. So these are the conditions that is given to us. So with this data, let us see how to do the drafting of this problem statement. So we shall begin the drafting by drawing the XY line. Construct the reference line. Annotate the line as X and Y, and also the reference planes as VP and HP. So now let us construct the top view of the cube. So the top view of the cube will appear as if it is a square. So now let us proceed towards constructing the top view of the cube, and the resting condition is on one of its edges. So now we shall consider constructing the square, which is nothing but the top view of this particular cube, which is measuring 40 mm. So let me draw a line of length 40 mm. So since it is a square face, both the width and the length will be equal to 40 mm, and in the front view the axis will also measure 40 mm. So this completes the first step, that is constructing the top view. Now let us annotate this cube. So we'll tell that initially it is resting on one of its base edges A1 and B1. So A1 and B1 mark the edges of the bottom face of the cube, whereas A and B marks the corners on the top face of the cube. So this is A1, and this is B1 inside the bracket, which is not visible. And similarly, this is C1, and this is the corner D1. So now let us draw the axis. So let us mark the axis. So the axis is just an imaginary line, and hence I'm not using the thick lines for this. It is only to consider the reference point for the axis. So from here, let me draw the projection lines in order to complete the front view of this cube. So from each of the corners, I'm drawing the projection lines. Let me just indicate the directions of these projection lines, and also annotate the axis So O is the axis on the top face of the cube and O1 is the axis on the bottom face of the cube. So now let us draft the front view of this cube. So the axis will also measure 40 mm since it is a cube. So let me draw the axis line again, which is a thin line, and then complete the front view by joining the end points of the projections. So this is the base of the cube and this is the top face of the cube. And next, the outer edges on both the sides. I'll complete this. So with this, I finish drafting the front view of the cube, which also appears as if it is a square of 40 cross 40. Now let us do the annotations. So the observer is going to look from this direction, and for him the corner B1 is visible first. So it is B1 dash, and inside the bracket it is A1 dash. Similarly, the top faces B dash and A dash. And coming to the axis, this is O1 dash and this is O dash. And similarly, this corner here is C and then C1 and C dash, C1 dash and D1 dash. And similarly here it is C dash and D dash, because the corners C is visible first when the observer is going to look from this particular direction. So the front view and the top view of the first position is complete for the cube. So as per the problem statement, it is a cube of 40 mm which is resting on HP on an edge, and this edge is going to be inclined to the vertical plane in the later stage at an angle of 30 degrees. Okay, so now we'll move for constructing the second position. So for the second position, we need to take the clue from the inclinations that is given to us. So in the second position, it is the lateral square face containing the edge on which it is resting is inclined to the horizontal plane at an angle of 50 degrees. So it is nothing but it is resting on one of its edges A1, B1. So the lateral square face is the one which is going to emerge from that edge, and that face is A1A, B, B1. So that face is making an inclination with respect to the horizontal plane at an angle of 50 degrees. So now let us proceed to understand how this 50 degrees can be constructed. So you can just see that this edge in the front view, that is B1 dash A1 dash and B dash A dash and also O dash O1 dash, these are lines which are parallel. So if I'm making an inclination of the axis at 50 degrees, even this edge will also be inclined at an angle of 50 degrees because there will be the alternate interior angles. So now I'll construct the base inclination angle, which is equal to 90 minus the axis inclination, that is 50. So now let me just proceed towards the next step for constructing the base inclination angle. So I'll consider one arbitrary point on the XY line, and from this arbitrary point I'm going to draw a line which is measuring 90 minus 50, which is equal to 40 degrees. So on this 40 degree line, I'm going to transfer the base of the cube. So this is 40 mm. So I'll just transfer the base of the cube first. And next, from each of these corners, I'm going to draw the 90 degree lines, which are the edges of the cube. So I'll mark 90 degrees, and here also I'm going to mark 90 degrees. So now I'll be transferring this rectangular edges, that is the straight lines. So you can just see that each line here is going to measure 40 mm, that is 4 centimeters, and now I'm going to transfer the same. So you can just see that each line is measuring 40 mm, and similarly I will just transfer this line using the set squares. and also the reference of 90 degrees. And now I'll complete the top face of the cube, which is also again perpendicular line. So better use the set square to draw these perpendicular lines. So now this completes the front view. However, I need to show the axis, and the axis is exactly at the midpoint. So let me just mark the midpoint of this edge line, which is at 2 centimeters, that is 20 mm from this origin point. And this will also be a straight line. So let me use the set square to draw the straight line. So just glide your set square as if it is parallel and mark the center point of this particular cube. And now let me draw the axis line. So now let me complete the annotation part. So this is B1 dash and A1 dash, and this is B dash and A dash. Similarly, this is O dash, O1 dash, and this is C dash and D dash, while this is C1 dash and D1 dash. So now you can just see that the axis is inclined at an angle of 50 degrees because we have constructed the base at 40 degrees. So now you can just see that the edge, okay, as given in the problem statement, is making an inclination of 50 degrees, correct? So this is the lateral square face of the edge on which it is resting, which is making an inclination of 50 degrees. So let us just indicate that parameter. So this is 50 degrees. Now let us proceed towards drawing the top view of the second position. So for that we require the horizontal projection lines and the vertical projection lines. So let me complete the vertical projection lines first. So this is one from B dash and A dash, and the next one is from O dash, and next is from the corners C and D. So ensure all these are exactly straight lines. And next we'll take the bottom face of the cube, that is B1 and A1, draw the projection lines, and from O dash draw the projection line, and also from C1 and D1 draw the projection lines. Now let us draw the projection lines sideways. So A to A1 and D1 and D. So it is going to meet the extreme projection lines, and this is the other edge, and next also from the axis, correct? So now before we complete the view, let us just do the annotation so that we can join the corresponding points. So this is the corner A, and this is the corner B from the top face, and next corner C is this. So this is the projection line. So this is the corner C, and this is the corner D, this intersection points. Well, this is the axis of the top face, which is O. And next we have got the other corners. So let us identify A1 and B1. So A1 is here, this is A1, while this is B1, and similarly this is C1 and this is D1. So before we construct the outer edges, let us identify. So the observer is going to look from this direction, and for the observer, the farthest corner points are B1 and A1. So all the edges emerging from these corners, that is B1 and A1, will be dotted. So let me complete this. So you can just see that the edge A1 to B1 is represented using a dotted line like this, okay, and the other edges will be completely visible. So let me complete. So AB is visible, so let me join that using a thick line or a continuous line, and the outer edges, that is A1, B1, D1, so all this will be completely visible. And next is C to D. So this is ABCD, which is the outer face of the cube, and A1, B1 is which is not visible, so it is shown using the dotted lines, okay. And next is A1, B1, C1, D1. So this is how the cube is going to look in its final position in the second view. So this is the axis point O1. So this O and O1 is the axis point. So let me just show the axis using a different color. So let me just complete drawing the axis line. So let me just draw O1 to O. So this is the axis of the cube. So in the second position, the lateral square face of the edge on which it is resting is making an inclination of 50 degrees to the XY line. Now we need to proceed towards the next position, that is the third position, wherein the edge on which it is resting is also inclined to the vertical plane at an angle of 30 degrees. So I need to draw a line which is inclined at 30 degrees first and then transfer the edge on which is resting at this 30 degree line. So for that, let me just consider one arbitrary point on the reference line and proceed towards drawing or constructing a 30 degree line. So keep your protractor origin at that reference point and mark a 30 degree line. So maybe if you're facing this problem, what is suggested is make a line which is offset from the XY line, make it a line parallel, and then from that line let us draw a 30 degree line. So this line, when extended, it is making an angle of 30 degrees. So on this 30 degree line, I need to transfer first the edge, that is A1 and B1. Okay, so also ensure that whenever you're transferring A1 and B1, so you're rotating your the cube on this 30 degree line, and when you're doing so, the outer edges, that is AB and D1 and C1, they must not cross the XY line. So that checkpoint is to be followed. So now I do know the edges, so let me just transfer. So that is the resting edge A1 and B1, which is exactly equal to 40 mm, and hence this is a non-beta angle because we are going to consider the parameter which is not changing its dimension. So I'm going to transfer this on the 30 degree line. So let me just annotate simultaneously. This is A1 and this is B1. And now if I'm going to draw a perpendicular line passing through A1 and B1, I'll be getting all these points, correct? So let me do that. So I'll mark 90 degrees from A1 and B1 as the reference. So this is A1 and this point is B1. 90 degrees is marked. So let me draw this 90 degree line first. So now let me measure from A1 to A and transfer that distance. A1 to A is approximately around 2.5 mm. So let me transfer that A1 to A as it is, using the thick lines or the dotted lines wherever it is in the second position. So it is 2.5 mm. Similarly, B1 to B is also equal to 2.5. Let me transfer that. B1 to B is 2.5. And next, let me consider marking the points from A1 to D1. So A1 to D1, if I'm going to consider it as around 3 mm. So I'll transfer that 3 mm line. Similarly, from B1 to the point that is C1. So let me annotate the edges. So this was A1 and this was B1. And from B1 to this is B and this is A, and the outermost corner points are D1 and C1. So now I need to identify the points D So A1 to D, if I'm going to measure this distance, A1 to D, it is equal to 0.5 mm. So I'll transfer that 0.5 mm. And similarly, this will also be symmetric. Let me use the set squares to draw the perpendicular lines. So this line is perpendicular, that is 90. So I'll just slide my set square and complete the 90-degree line from A1 to B1, and similarly from these 2 points to get the straight line, and then so let me annotate this. This is D and this corner is C. And to identify the axis, which is very important because we need to identify the length of the axis in the final position, so we'll just check out this value. So from A1, the axis line is exactly at the center at a distance of 2 mm. So at a distance of 2 mm, I'm going to mark the point, first point, okay? And from this point, if I have to draw the axis, so the total axis is measuring 2.5 centimeters. And on this line, that is A1 and B1, the axis is lying at 1.5 mm. So keeping the center point at 1.5 mm, I'm going to draw the axis length, which is measuring a total of 2.5 mm. So let me use the same color to show the axis. So if you're not comfortable with the scale, so just use a set square to make it a perpendicular or a parallel line. So just keep your set square like this and slide it. So it is 2.5. So I'll take one reference point. So just measure the distance. So this completes the axis. Okay, so now let me annotate the point. So this is O, the axis point on the top face, and O1, the axis point on the bottom face of the cube. So now let me extend the projection lines and complete the front view of the cube. So to do that, let me draw the vertical projection lines first. So I'll go from the top face. So this is from the corner B, I'm going to draw one vertical projection line. And from the corner A, I'm going to draw one vertical projection line. And next is C and D. So from C, one vertical projection line. So this is corner C, and from the corner D. So from the corner D, I'm going to draw one projection line. Correct. So now let me complete the top face of the cube. So from B dash, A dash, let me draw a horizontal projection line. And also from C dash, let me draw one horizontal projection line. And from O, let me take a projection line. And also one horizontal projection line from O. So let me just annotate the points first. so the points of intersection to complete the cube in the front view. So this point is from B and this is from B, so this is the point or the corner B of the top face. Next is this corner A and this is the corner A here, the point of intersection. Well, this is the axis O, and next I've got the corners C. So this is the corner C and this is the corner D. So I'll just complete the other positions later. Now that is joining the edges later. Now let me consider drawing the projection lines from the bottom face of the cube. So first is A1 and B1. A1 and B1, they are having their horizontal projections along the XY line itself. So A1, B1 is over. Next C1 and D1. So draw from C1 and also from D1. And then let me consider the horizontal projection line from C1 and D1. So let us annotate the points. So from A1, so this is A1 dash. So this is A1 dash and this is B1 dash. Similarly, include the prime symbol for the top view annotations also. Okay, so A1 dash and B1 dash is done. Next is C1 dash. So C1 dash is this, right? And next we have got the point or the corner D1 dash here. And next O1. So from O1, so this is O1 dash and this is O. So let me join this line first so that I get the axis. So this is the axis, and the length of the axis of the cube in the final position is equal to 2.5 mm. So that is the length of the axis of the cube in the final position. So now let us complete the cube position in the top view. So as you can see here, for the observer, the farthest corner point is the corner A. So all the edges emerging from the corner A will be hidden. So that is A dash to B dash will be a hidden line. And next the connection is from A to D. So A dash to D dash will also be hidden, or the dotted line. It is a hidden line represented using the dotted line. And similarly, the parallel edge from A dash to A1 dash is also hidden. And all the other outer edges are visible. So let me complete the bottom face of the cube now. So A1 to B1 dash. Similarly, B1 to C1. So this is B1 to C1, C1 to D1, D1 to A1. And next is from the top face. So B to C, let me connect. B to C and C to D. So now let me connect the parallel edges. So let me take up D1 to D first, which is parallel to A1 and A. And next is C1 to C. And next is from B1 to B. So this is how the cube is going to look in the final position, that is when it is resting on one of its edges on the HP like this, that is A1, B1, and the lateral square face emerging from that edge is making an inclination of 50 degrees with respect to the HP, and the edge on which it is resting, that is A1, B1, is inclined to the VP at an angle of 30 degrees. So you can just show the inclination. So this inclination, when you extend, it will be equal to 30 degrees. So let me just take a reference line and show the inclination as 30 degrees. So with this, we complete the problem. So the length of the axis is shown here, that is O to O1 dash, and that will be equal to 2.5 centimeters or 25 mm. So with this, we complete the problem. Thank you all for watching.